Hello, my lovelies! It's Susanna, and today I want to show you how to solve this problem. A 20-meter long stick lies on a circular ring. It touches the inner circle and extends exactly to the outer edge of the ring on both sides. What is the area of the ring? Okay, let's take a look at our picture here. We have our circle, and here is this 20-meter long stick that touches the inner circle at this point here. We have to find the area of our ring. I call this area A, and it consists of the area of the big circle. I call this area A1, so we take A1, but this would be too much because we're not interested in the area of the small circle here, so we have to subtract this area. I call this area A2, and we subtract it from our big circle. Okay, let's find the formulas for our areas. We start with the big circle. In general, if we want to find the area of a circle, the formula is pi times the radius squared. So we just have to find the radius of our big circle. It goes from the center to the edge of our circle, and I just call it x. We don't know the radius yet, but for the formula, we have pi times x squared then, and we subtract the area of the small circle. We also need the radius for that. We don't have it yet, but from the center to the edge of the small circle, let's call it y. So this is our radius, and for the formula we have pi times y squared. Okay, this is our plan. If we have x and y, we can find the area of our ring. So let's try to find the values of x and y. We haven't used our stick yet. The stick touches the inner circle at this point here and the outer circle at this point here. So these are important points. So maybe we draw the radius not here, just somewhere, but our radius of the big circle, we can draw it from the center of the circle here and connect it with this important point here. So this is x, and our y is also just somewhere. We can connect it with this point here. So we don't want to draw the radius here, but we draw it here like this, and this is y. Now we've built a triangle, and this is actually not any triangle, but a right triangle. Why is that? Well, our line here touches our inner circle, right? So it is a tangent to our circle, and any tangent is always perpendicular to the radius at this point where it touches. So we have a right angle here, and we can use the Pythagorean theorem in this triangle to find a connection between x and y. So let's start with this. We only need the length of this side here, but it is half of the entire stick, which is of length 20. So half of it equals 10. This is the length of the part we need here for our triangle. For the Pythagorean theorem, we need the hypotenuse of our triangle first. That's the side that lies across the right angle. So this is our hypotenuse. And the Pythagorean theorem says then take one of the other sides, so the y, and square this. Then add the other side and square it, so the 10 and square it, and then you get the hypotenuse squared, so you take your x and square this as well. Okay, we found an equation. I mean, there's x and y as unknowns in here, so we can't just solve the equation for x or for y. We could maybe calculate 10 squared, which equals 100, so it makes it a little bit better. But do you remember that we had x squared and y squared at the beginning as well? So let's take our equation that we just found. I wrote it down here again, and this is what we had at the beginning. Here's x squared and y squared in here as well. Okay, there's also the pi in here as well, which makes it look a little bit more difficult, but maybe we can factor out the pi. So our area is pi times, and what is left in the parentheses? If we take out the pi here, only the x squared squared is left, then we have our minus, and here if we take out the pi, only y squared is left. So we have x squared minus y squared here. And if we take a look at our equation here again, we only have x squared on this side, but we can take the y squared from the other side to the right by subtracting y squared on both sides. So we get y squared minus y squared cancels out, so we only have the 100 on the left side. And on the right side, we have the x squared, and we subtract the y squared. And can you see that this is exactly the same? So instead of writing this, we can just write 100. So this is pi times 100. Or if you want to switch these two, 100 pi, which I prefer. And we found our result. This is the exact value of our area. If you want to calculate this, then you get an area around 314.16, and so we solved our problem. I hope you enjoyed it. Please like the video and subscribe, and we see each other in one of my next videos. Take care!